Okay, so here we're going to study another type of two-dimensional motion, which is circular motion. So in this type of motion, we have an object moving with the same speed, with constant speed on a circle. So let's look at an example of this. So this is a ladybug, and so now we're going to see it moving in a circle, right? So we're going to see it moving in a circular motion. So here, she's describing a circle right there. And so the key feature here is that the speed never changes. The circle has a radius r. So now let's show the velocity vector. You can see the velocity vector here. And one feature of the velocity vector is that the magnitude never changes. However, the direction of the velocity vector changes. Now look at the acceleration. The acceleration is always the same, pointing towards the center of the circle. So this is an example of circular motion. So let's look at a more descriptive wave here. So we have the circle, an object moving in a circle here. We have velocity vectors. They always have the same magnitude. Direction of the velocity vector is changing, and the acceleration that causes that change in the direction of the velocity vector always points towards the center of the circle. We call this acceleration centripetal acceleration. Let's look at a simple question here. We have a car traveling at 45 miles per hour, and the question is this car accelerating? Take a minute to answer this question. And the answer is yes, because, well, if the car is here, then the velocity vector is going to be something like that. It's going to have the same magnitude as this green vector, but it's going to have a different direction. So in going from this point to this point, the direction of the velocity vector has changed. Therefore, delta v is not zero, and delta v over delta t, which is the acceleration, that is also not zero. So let's understand a little bit about acceleration. Here we have a circular motion, and we take a segment, and the object moves from 1 to 2 here, right? It moves along this circular path, and it's going to continue moving. This is a big circle, right? So then we see the vector displacement that goes from 1 to 2 is this blue vector here, and it forms an angle, a triangle here. This is a triangle, and this is an angle theta. So in that triangle, then, we get that at 1, this is the velocity, and at 2, this is the velocity. I can slide the vector from 1 and put it here, and this is what I'm going to get. And then the question is, what is delta V? Well, delta V, let's do this. So delta V is V2 minus V1. V1 would be this vector here. This is minus V1, right? So I'm going to use the tip to tail method. So minus V1. So then V2 minus V1 is this vector that goes like that. So now I can draw these three vectors in this way, right? So I'm going to write V2 here, and then this is delta V, and this is V1. So we have V1, V2, and they make a triangle. So let's look at this in a picture here. So this is V1, this is V2, and this is delta V. And this triangle here is very similar to this triangle, where this is R, and this is a segment of the circle here, right? This is D, and this is R. So then I can say that delta V divided by V, delta V divided by V, is equal to D divided by R, right? Because these two triangles are similar. So I'm going to use this property to find the magnitude of the centripetal acceleration. So we know delta V is equal to D divided by R because this triangle is similar to this triangle. So let's look at this simple math here. So we have D is equal to the velocity times delta T. And then, so I can go and divide this by R and divide this by R here. So D over R then is delta V over V. So I get delta V over V is equal to V delta T over R. So now I'm going to take the delta t and put it here, and this v I'm going to put it over here. So when I do that, I get that delta v over delta t is v squared over r. And this is the acceleration. That is the acceleration, so the acceleration is v squared over r, and that is the magnitude of the acceleration. The acceleration has a magnitude of v squared over r and always points towards the center of the circle. Question. You have a toy car, moves around in a circular track at constant speed. So suddenly the speed doubles. So what is the change in the acceleration? Is it 1/4, 1/2, 2, or 4? Take a minute and then come back. So remember, the acceleration is then v squared over r, right? So if the velocity changes, if the speed changes by 2, then this is 2v squared over r. And so this is equal to 4v squared over r, so the change is 4. And that is the right answer. So let's do one simple example here. We have female short track speed skaters that can cover 500 meters in 45 seconds. So, and they have to take turns they have a radius of 11 meters. So that's the radius of the turns, right? So you have to take a turn, and this radius here, that's 11 meters. What is the magnitude of the centripetal acceleration in a turn? So centripetal acceleration again is v squared over r. So we need to find the velocity first. So the velocity is 500 meters in 45 seconds. That gives me 11 meters per second. So I know the radius is 11 meters, so I can do 11 meters per second squared divided by 11. That gives me 11 meters per second squared. So that is the acceleration. As a point of reference, remember that gravity is 9.8 meters per second squared. Thank you.